Welcome students for the maths class of grade 10. Today we are doing exercise 21b. First questions first. Cos A upon 1 minus tan A plus sin A upon 1 minus cot A is equals to sin A plus cos A. LHS, we have cos A upon 1 minus tan A plus sin A upon 1 minus cot A, which can be written as cos A upon 1 minus tan A can be written as sin A upon cos A plus sin A upon 1 minus cot A can be written as cos A upon sin A, which is equals to cos square A upon cos A minus sin A. What happened here? We had taken the LCM in the denominator, so it becomes cos A minus sin A, and this cos went up, so it becomes cos square A plus sin square A upon sin A minus cos A, which is equals to, now in the denominator you can see cos A minus sin A, and here sin A minus cos A. Denominator we want to make same, so what we are going to do now, cos square upon cos A minus sin A. If I remove minus sin A from if we remove minus sin from here, so it will be minus sin square A upon cos A minus sin A. Now denominator becomes same. Here we in place of plus we got minus, so now we have cos square A minus sin square A upon cos A minus sin A, which is equals to cos A minus sin A upon cos A plus sin A upon cos A minus sin A. Cos A minus sin A get cancelled. Remaining is sin A plus cos A, which is equals to RHS. What we have to prove. This was your question number 1 first. Now question 1/3, we have tan A upon 1 minus cot A plus cot A upon 1 minus tan A. So take LHS. We get tan A upon 1 minus cot A plus cot A upon 1 minus tan A. So we can write this one as tan A 1 minus cot can be written as 1 upon tan A plus cot A upon 1 minus 1 upon cot A, which is equals to, again in the same manner, tan square A, tan A minus 1, we had taken the LCM, plus cot square A upon cot A minus 1. Here we have tan square A upon tan A minus 1, and here we have cot square A upon cot A minus 1. Now we had taken here tan A upon 1 minus 1 upon tan A. Here we will keep as it is, that is 1 minus tan A, 1 minus tan A, so it will become tan square A upon tan A minus 1A. Here we was having plus cot A upon 1 minus tan A, which can be written as, now the denominator you see here tan A minus 1 and here 1 minus tan A, so it can be written as tan square A upon tan A minus 1, taking minus sign common, so it becomes minus cot A upon tan A minus 1, which is equals to tan square A minus cot A upon tan A minus 1. Now tan square A can be written as sin square A upon cos square A minus cos A upon sin A upon sin A upon cos A minus 1, which is equals to, now when you're taking the LCM, so it becomes sin cube A minus cos cube A upon cos square A sin A upon sin A minus cos A upon cos A, which can be written as sin cube A minus cos cube A upon cos square A sin A into cos A upon sin A minus cos A. So cos A get cancelled, cos A get cancelled. So we are getting now A cube minus B cube. That identity we are going to use. So here it will be sin A minus cos A sin square A plus cos square A plus sin A cos A upon cos A sin A into sin A minus cos A. This part get cancelled. 1 sin square A plus cos square A can be written as 1 plus sin A cos A upon cos A sin A, which is equals to 1 upon cos A, which is equals to 1 upon cos A sin A plus sin A cos A upon sin A cos A, which is equals to 1 upon cos A will be as sec, 1 upon sin will be cosec plus 1, which is your RHS, hence proved, hence proved. Now next question 1.8, 1 plus tan A into tan B the whole square plus tan A minus tan B the whole square, which is equals to sec square A into sec square B. So LHS, we have 1 plus tan A tan B the whole square plus tan A minus tan B the whole square. When you are opening it, we get 1 plus tan square A tan square B, 1 square, that's 1, tan square A tan square B plus 2 tan A tan B plus tan square A plus tan square B minus 2 tan A tan B, tan B. Now what we are having, 1 square will be 1 minus 2 tan A tan B and plus 2 tan A tan B get cancelled, so we get 1 plus tan square A tan square B plus tan square A plus tan square B. Now what we are going to do, I am bringing 1 plus tan square A plus tan square A tan square B plus tan square B together. So from here we are having, if we are taking it together, 1 plus tan square A we get as common. From here tan square B is common, tan square B, so we get tan square A plus 1, as both the brackets are having the same value, so 1 plus tan square A, 1 plus tan square B. We have a formula, 1 plus tan square A is equals to sec square A and 1 plus tan square B will be sec square B, which is equals to RHS, hence proved. Now question number 2, if m is equals to x cos A plus y sin A and n is equals to x sin A minus y cos A, to prove that x square plus y square is equals to m square plus n square. So right now we have the value of m and n, so we are taking RHS. Doing the substitution in place of m square and n square, what we have, x cos a plus y sin a the whole square plus x sin a minus y cos a the whole square. When you're opening, we get x square cos square a plus y square sin square a plus 2x y sin a cos a. From here we have x square sin square a plus y square cos square a minus 2xy sin a cos a. So minus and plus get cancelled. So bring the like terms together. So we have x square cos square a plus x square sin square a plus y square sin square a plus y square cos square a. What is common? X square common, so it becomes cos square a plus sin square a. From here y square common, so sin square a plus cos square a. X square a into 1 plus y square a into 1. Why 1? Cos square a plus sin square a is equals to 1. So we did the substitution. So x square plus y square, which is equals to LHS, which is equals to LHS. Now question number 7, we have LHS. What we have LHS? M square plus n square cos square b. So value of m and n we have. M we have cos a upon cos b the whole square plus cos a upon sin b the whole square, big bracket, cos square b. This is the question. Then we get now cos square a upon cos square b plus cos square a upon sin square b cos square b. Taking the LCM, so we get cos square a sin square b plus cos square a upon cos square b sin square b cos square b. Cos square b get cancelled. From here cos square a is common, so we get cos square a, and from here we have sin square b plus 1 upon sin square b. So what we are having, cos square a upon sin square b, and here sin square b plus 1 that we got. And what they are asking to prove that it is equals to n square. So n square we have cos a upon sin. That means this has to be cancelled. So how it is going to be cancelled, just we will see now. Now when you are taking the LCM, cos square a sin square b plus cos square a cos square b cos square b get cancelled, so we get cos square a as common. So what is left? Sin square b, and from here we have cos square b upon sin square b, which can be written as cos square a upon sin square b, and sin square b plus cos square b into, which is equals to 1. Now cos a upon sin b the whole square, which is nothing, it's a n the whole square. Hence proved.